All right, boys and girls, welcome back for a remix. Trying to get you some help with implicit differentiation. This is my third try. I was happy with the video yesterday, and then I watched it again, and it didn't have audio. It's frustrating, but we're just going to do our best. So this is kind of a rehash of yesterday's video with audio. I want you to think about this equation here. X squared plus y squared equals 25. Okay. Now, that is the equation of a circle. And you should know that that is not, by definition, a function. A function is something that could be expressed usually in terms y equals a function of x, so that it's one-to-one, meaning for every input, there's a unique output. Anyway, if you remember the vertical line test, this vertical line test would fail. That's how we would know it's not a function, but we use that word function kind of liberally here. Now, remember that typically a function is y equals f of x. Y and f of x, you guys have been switching these for years. That's going to kind of be important in understanding this. Now, let's look at right here. This would be the point 5, 0. And this would be the point 0, 5. This is the point 2.5 radical 2, 2.5 radical 2. And this is the point negative 2.5 radical 2, positive 2.5 radical 2. Just keep that in mind for a little bit later. Okay. Now, let's differentiate this equation implicitly. So to do that, you got to take the derivative of both sides with respect to x. So you get 2x plus 2y times dy dx. Why am I kind of adding on or multiplying by an additional factor of dy dx? Well, here's why. Because y is a function of x, and we're taking the derivative of this thing with respect to x. So this thing itself is a function. So you kind of have to apply the power rule. It's 2 times the function, which is y, to the first power, times the derivative of the function. And you're always going to multiply by a factor of dy dx. And anytime you're integrating a y variable with respect to x. The derivative of 25 with respect to x is 0. Okay? Now, we want to solve this thing for dy dx. So subtract 2x from both sides, and you have 2y dy dx equals a negative 2x. So then divide each side by 2y, and you get dy dx is negative 2x over 2y, which is negative x over y. What that is telling you, this dy dx is the slope of the tangent line at any point. These are the points you can pick. So let's pick this point, the point 5, 0. At that point 5, 0, the slope will be negative 5 divided by 0. You can't divide by 0. That is an undefined slope. Good. That's what it looks like. What about this point, 0, 5? You get a negative 0 divided by 5. The slope of that line is 0. Good. That's what I thought. What about at this point? You get a negative 2.5 radical 2 divided by a positive 2.5 radical 2. Okay. This slope is negative 1. This slope here was undefined. This slope was 0. And let's look at one more. If I take these values and put them into this equation, I get a negative negative, which is a positive, divided by a positive, and this slope is 1. Okay? So I hope that helps you understand what you are actually doing. Now let's take a look at one that might be a little bit harder. This might be a little different than the one in the video I did yesterday, but it's the same concept. What if we just said differentiate? This would be the directions. Differentiate with respect to x. I might even say that, okay? And what if you had y cubed plus y squared minus 2y plus x squared equals 6? They wanted you to differentiate that. Okay, well, first thing you do is just differentiate each thing with respect to x. So this is 3y squared times the derivative of the function plus 2y times the derivative of the function minus 2. This is the one that I tend to forget about or leave out. This is still times y to the 0. So y to the 0 is 1. It's gone. But you still need a factor of dy dx. You're still going to apply the power or the power rule. Plus 2x equals 0. Okay? Now I'm going to do two things in this step. I'm going to subtract 2x from both sides. And I'm going to factor out a dy dx. You get a 3y squared plus 2y minus 2. Okay, so what we're going to get is dy dx times 3y squared plus 2y minus 2 is negative 2x. This is pretty typical. Now we want to find this, so we got to divide each side by 3y squared plus 2y minus 2. So you end up getting, these cancel just like every other equation you've ever solved. You end up getting dy dx is negative 2x over 3y squared plus 2y minus 2. So at any point, this is how a change in y over a change in x is related. So you could take any point that satisfied this original equation and plug it into this equation and find the slope of the tangent point. You kind of get an idea of how things are changing at that point. Okay? I hope this helps. Boom!